let's discuss the number of invertible matrices there are of dimension n, so n by n, square matrices, invertible, over a field where the dimension of the field is, let's say, call it D. So if we have that, well, the number of such invertible matrices that exist over this finite field is going to be take the number of elements in the field, take it to the power of the dimension of the matrix, subtract, again, the same D, but we start with 0 power and we multiply this term by the same thing, but we increase the 0 power to 1 and gradually always by 1. So it continues like this as a product until we reach d to the n minus d to the n minus 1. That's the idea. So if we take an example for this, let's take, for example, A is 2 by 2 over, so that means a matrix 2 by 2 with 4 entries, of course, over field Z13. Well, Z13, so Z13, what we know here is Z13 has 13 elements. So according to the formula we just shown, it's going to be d to the n minus d to the 0 times d to the n minus d to the 1 until we reach d to the n minus d to the n minus 1. D is the number of elements in the field, that's 13. Then n is we have a 2 by 2 matrix, so that's a small number, that's this 2 right here. We subtract d to the 0, which is this, and we continue until n minus 1. Well, actually we only continue once here because we directly get to n minus 1 because n is 2, so n minus 1 is this time 1. So it's already the first iteration. We don't have to reach to a higher d to the n minus 1 in this case of a 2 by 2 matrix. We have 13 to the second minus 13 to the first, and that's it. We go to n minus 1 with the 1 here. So the result is going to be one can look for the concrete result, but just evaluating the powers is this product of these two numbers. So that's it for this example. Let's take a more complicated example where there's more of the iteration. So to just repeat, it's d to the n minus d to the 0 times d to the n minus d to the first until d to the n minus d to the n minus 1. And that means that if we have, so example would be, for example, we have a field, we have a matrix that's 3 by 3, and we have a field. The field we choose will be just Z2. Z2 has 2 elements, so that's going to be a small number this time, but there's going to be more entries of the matrix. So the calculation goes still the same idea. We take the number of elements in the field, power it to the dimension of the matrix, minus the same but to the 0 power. We increase the right terms power by 1 until it reaches n minus 1. So, and with 2 to the second, that's it, because 2 is 3 minus 1 this time. We have matrix of dimension 3 by 3. So this is going to be 7 times 6 times 4. All right, so this was another example of the same. It's always this sort of calculation. And of course, we showed examples with finite fields because there it makes sense to calculate a number like this. And you can try it with different sorts of fields for practice.